So we played with this idea that maybe we can have an employee which is a class that maybe uses some encryption API to encrypt and decrypt data. But let's do some demonstrations with this. And perhaps when I create an employee, I could have another method in this class, make secure, right, which takes an object which supports an I encrypt object, and does the following: make secure maybe is a void method, right? And it maybe it's a private method, and we'll make it a static method because it's in the same class with the main method. So to make all of this more reasonable, what I'm going to do is call make secure this employee that I've created. And for now, I will just get rid of this of some of these other examples here. Okay, so let's see. So I have this method make secure, which takes an interface as a parameter, but I have an object which supports an interface, and I pass this object to a method such as make secure, which takes an object of type of that encryption interface. All right, so let's then inside here we can say object we can say set encryption key, right? And encryption key will be secret, right? Something like that, encryption key. And then we can say object dot encrypt, and encrypt data object encrypt. I think I will change my mind, and instead of using any kind of parameters there, I will just go to my encrypt interface and delete the string. We'll just say that the object already has some data that it wants to encrypt, and it has to know how to encrypt it. And inside my employee class, I do the same modification. I remove this, and I will basically encrypt secure data in place. So back to the main method. So this is the plan. Let's say that we also say employee print, right? So we make it secure, then print. So this should become unprintable, and we should see some garbage. But then if we say employee decrypt, right? If we decrypt the employee, and then if we say employee print again, it should become sort of like usable again. Okay. So these are the some stages in our program. First, we create an employee. This is main method, right? So we create an employee instance of an employee class. You create it as an employee, and we pass it by reference to a method which takes an interface which uses encryption interface, apparently uses a special encryption key named secret, and does the encryption. Right. So then we will attempt to print the employee, and it should be not very easy to do because we will encrypt the data inside the class. As we move along, we will decrypt and try to print it again and to see if we can make it again readable. So let's see. In order to encrypt something, we need to make that employee class to have some payload, right? So maybe we will have a constructor for this class, public employee, which takes an employee name, string name, okay, something like that. And it's very simple constructor. We will add a name parameter here, right? So we will add the name, and we will simply say this name equals name. So we have a constructor which takes an employee name and will attempt to encrypt it. So let's then, of course, in our main class, you cannot create employee now using the default constructor, so we will use a specific constructor, and we say Joe, right? So Joe, right there. Okay, so let's see what we can do. Right now, by the way, we need to go to employee and revisit all of this, and our print will basically say system .out.print print line, maybe print line, and we will print the name. So right now encryption really doesn't do anything for what we do, and we can then basically at a minimum, when we say encrypt, we say encrypt, then we can say name equals encrypted, right? So which means no longer readable, and we can return that name from here, right? And when we say decrypt, we will basically decrypt and return name. I kind of invent things as I move along, so bear with me. Decrypt, right there. Decrypt, then basically return the name. So essentially I'm trying to do this in place, and as far as I can see, maybe I no longer need the secure data at all. All I need is basically the key and employee. So let me save this and run it. Right? So if I encrypt, everything is encrypted, and it's just a mock-up of the actual implementation. So let's implement some sort of an encryption here. In main class, I have an encryption key, which is a secret. So when we say encrypt inside the object, let's try something very, very simple. What we can do is we can say maybe we can extract, it may be easier to work with bytes, so we can say byte array key bytes equals key get bytes, right? So this specific method converts a string into bytes, okay? And so this time, instead of saying encrypted, we'll see what we can do with this. return name. So let's do another one. We can say byte name bytes, and get name bytes. Okay. Then I'll probably won't say encrypted anymore. Instead, we will have a loop, a for loop, which uses an index, integer index, which will start with 0, right? And we will say for as long as index is less than key bytes, a length, as with any array, and implement index. We can then say that name bytes with this specific index equals name bytes exclusive OR with the key bytes of the same index. This is interesting. What kind of name bytes, key bytes? Just trying to understand what the error message is going to be here. Let me compile this. Also conversion from int to byte. And this is on this line here. So, Perhaps I'll just try brute force using telling the compiler, don't worry about losing any information. I'll explain in a second what I do here. Basically, I combine one byte with another byte, and using an exclusive OR operator here simply to apply a symmetric type of encryption here, brute force. Okay, so name bytes, so we take the name, and then the name, once the name is encrypted, we can say name equals new string, and we will construct that string from the bytes that we just made up. Okay, let's try this. So this is my version of encryption, and I'll go over it in a, step by step in a second.